Okay, so for this first part of section 3.5, we're going to look at how to use the distributive property in multiplying polynomials. So what you have to remember though is the distributive property itself. The distributive property states that what we can do oh, my pen's all messed up. What we can do is if we're trying to multiply 3 times this binomial, remember this is a binomial because it has two terms, 1, 2, each of these being terms. So when we take this 3 and we multiply it by that binomial, we get 3a plus 3b. And if I taught you last year, or you may have had another teacher that mentioned maybe this might be simply called bombing. So we bomb that into the brackets. Both of those, we go 3 times a to give us 3a, 3 times b to give us 3b. That's simplistically what the distributive property is. Now we can also apply the distributive property to, well, in this case, a binomial times a binomial. Okay, so that's what we'll be looking at. Polynomials in the form of x squared plus bx plus c. So this is with a form that our polynomial is going to take once we've done our distributive property. So when we multiply two binomials, we can use the distributive property like this. So example 1, expand and simplify. So expand, we do the distributive property. Simplify, we combine like terms. So we're going to expand and simplify this binomial, c plus 3, and this binomial, c minus 7. Okay? So I'm just going to blow this up, and I'm going to go c plus 3 and c minus 7. If we are truly thinking about the distributive property itself, we're going to split this up. We're going to think, okay, we have to multiply this c by this c minus 7, c times c minus 7, and we have to multiply this 3 by this c minus 7 as well, plus 3 times c minus 7. And from here, we can just simply use our distributive property like we've known in the past. C times c and c times minus 7 and 3 times c and 3 times minus 7. Which will give us c times c is c squared, c times minus 7 is minus 7c, 3 times c is plus 3c, and 3 times minus 7 is minus 21. There's our expansion. Now we simplify. We look at our polynomial and we combine the like terms. Are there any other c squareds? No, so I write c squared. Are there any other c's? Well, we have minus 7c and plus 3c. So minus 7 plus 3 is minus 4c. And then, of course, our last one, minus 21. No other constants. Constants are terms that have no variables attached, so no other constants. Minus 21. That is using distributive property to expand the binomial c plus 3 times c minus 7. Now, if we are multiplying a binomial times a binomial, or multiplying two binomials together, there is an acronym for a set of steps that you can follow in order to multiply that out. And that acronym is called, I'll do this in a different color over here, it's called FOIL. And what it stands for is first, outside, inside, and last. And I'll show you how that works. C plus 3 multiplied by c minus 7. F, FOIL, first two terms multiplied together. C plus c, or c plus c times c, c squared. Oh, outside two terms. The outside two terms, I'll do that in a different color. Outside two terms, c times minus 7. Minus 7c. Inside, I, inside two terms, 3c. And the last two terms in each binomial, I need a color, let's go with pink. Last two terms gives us minus 21. And again, from here, Combine your like terms to get c squared minus 4c plus, or sorry, not plus, minus 21. Exact same answer, but we followed this acronym. The first two terms of the polynomial, which I did in red, the outside two terms of the polynomial, which I did in blue, the inside two terms of the polynomial, which I did in green, and the last two terms of each binomial I did in pink. FOIL, first, outside, inside, last. And you can use either or, distributive property as it's laid out here, or FOIL as it's laid out here, to still get to the exact same answer. So as I work through the rest of the examples, example 2, example 3, and whatever else we come across, I'm going to use both, and once we get rolling on this, you'll see how fast expansion of binomials can actually go.